Okay, today we are going to learn how to compare decimals. All right, so let's say we had some problems that look like this, and we were asked to compare them with greater than, less than, or equal. So let's give this a try. So if I'm looking at this first problem, I know I have 0 and 18 hundredths, and I'm comparing it to 0 and 65 hundredths. Well, if I'm looking at this model, I can see 18 hundredths is definitely a lot less than 65 hundredths. This is a lot more shaded. So 65 hundredths is greater. Remember, the little alligator eats the bigger number. It's very, very hungry. So that one's pretty simple. So let's look over at this other one. This is where things get a little trickier. So here I have 0 and 14 hundredths versus 1/10. Now, a lot of kids will look at this right away and say, well, hey, isn't 1 less than 14? And that would make 1/10 greater? Well, not really, because if I'm looking at 14 hundredths, I can see that there is 1/10 inside of that model, but there's also an additional 4 hundredths. If I was to turn this other model into hundredths, and that 1/10 doesn't go away, it's still there. I could see that, well, wait a minute. 1/10 is the same thing as 10 hundredths. So if I'm really being careful, I would see that, wait a minute, that 14 hundredths is actually more. So my tip is, if you are only given a number that has tenths, you need to make it also have hundredths. Since I know that 1/10 and 10 hundredths are the exact same thing, I can answer this question a lot more easily. So I can see that, well, 14 hundredths is definitely greater than 10 hundredths, so 14 hundredths is greater. So same thing on this third one down at the bottom. I have 2 hundredths versus 2 tenths. Well, 2 hundredths is a pretty small amount. It's only 2 out of 100, 2 hundredths. But if I use that tip and I say, okay, well, this only says 2 tenths, but I want to make them both have hundredths, I can do that by just putting a 0, because I know that 20 hundredths and 2 tenths are exactly the same thing. Now they're very easy to compare. I can see I have 2 hundredths versus 20 hundredths, or 2 tenths, same thing. Ooh, where did my 0 go? Let's put you back. So 2 hundredths versus 20 hundredths. Well, 20 hundredths is definitely more. And if I'm looking at the model, I can see, well, yeah, 2 tenths is a lot more than 2 hundredths. So let's use that same strategy over here. Oh, these numbers are incorrect. That is not what these are showing. Ignore that. Let's see how much we do have here, though. This looks like it's 9/10, which written as a decimal is 0 and 9/10. And over here we have 90 hundredths, which written as a decimal is 0 and 90 hundredths. So at first glance, I would say, well, wait a minute, 90 is definitely more than 9, so that's gotta be more, right? Well, not necessarily. If you look at these two models, this 9/10 and 90 hundredths are actually the exact same amount. So we're going to use that strategy where if we only have tenths, we want to also make it have hundredths. We're going to put that 0, and whoa, these are actually exactly the same thing. If I did it with my fractions and I multiplied by 10, I would also get 90 hundredths, which means these two decimals are equal to each other. All right, so what if I didn't have any models and I was just asked to compare? Well, we can use that same strategy. So if I look at 0 and 3 hundredths versus 0 and 3 tenths, I want to make this one have hundredths also so that they're easy to compare. So I'm going to just put that 0. And now I can see, wait a minute, okay, 3 hundredths is definitely smaller than 30 hundredths. So 30 hundredths is larger. All right, over on this next one, I'm given a decimal and then I'm given a fraction. Oh, that can get so tricky. But really, it doesn't have to. I can either change my decimal to a fraction or change my fraction to a decimal, either way, and I can compare like that. So again, if I have this decimal 0 and 3/10 and it doesn't have hundredths, I can put that 0 to make it have hundredths. Now I have 30 hundredths. All three of these are equal to each other versus 17 hundredths. And I know, well, 30 is a lot greater than 17, so 30 hundredths is greater. So this 3/10 is actually greater than 17 hundredths. Let's look at this next one. Same strategy. I don't have a hundredths, so I'm just going to put one there. And then that becomes very easy. I have 0 and 40 hundredths versus 0 and 14 hundredths. 40 is definitely more. So be careful. You could also say then that 4/10 is greater than 14 hundredths. And if you visualize a model and I had 4/10, that means I have 4 of those stripes getting colored into a hundredths model. That's a terrible model, but you know what I mean. Versus 14 hundredths, which would only be 1/10 and 4 tiny little ones at the bottom. And so this one is definitely going to be more. All right, let's look at this next one. We have the same problem. We were given a fraction, and the other one we're given a decimal. So there's lots of things you could do. You can just put that 0, and now I have 60 hundredths versus 15 hundredths. Well, 60 is definitely more than 15, so that's done. But if you still were not sure, you could change that to a fraction and say, okay, I have 60 hundredths versus 15 hundredths. Well, yeah, definitely 60 hundredths is still much greater. If I wanted to say, well, I don't want to use fractions, I just want to use decimals, I can write that one, 15 hundredths, as a decimal. Then I can see 15 is still a lot less than 60, and so my answer is still correct. All right, what if you get whole numbers that are not 0? Oh my gosh, this is just getting crazier and crazier. But don't let it get crazy. Think about whole numbers. If you have the whole number like 4 versus the whole number 5, well, which one's greater? Well, yeah, 5 is greater. 5 is more value. So a lot of times tests or teachers, Mrs. Kemmer, will try to trick you by putting decimals that are all crazy, but really just start with your whole numbers. I have 17 versus 1. Okay, what's greater, 17 or 1? I don't even have to look at these decimals. I'm just looking at these whole numbers. 17 is a lot more than 1. Another trick that actually works really well for this, for some reason, if you go like this in front of it, all of a sudden kids really understand which one is more. Yeah, wouldn't you rather have $17.31 than $1.73? If I did that same trick over here and just turn these into money, all of a sudden, whoa, kids are like, oh, I know which one it is. All right, so this one has 5 and 5 hundredths. If I was looking at this as money, I would say $5.05 versus 5 and 5/10. Remember, if we don't have a hundredths, we want to put one on there. So now, all of a sudden, now this says $5.50 or 5 and 50 hundredths versus $5.05. So you want to have that extra little bit of change. So $5.50 is definitely more. But even if you were not thinking about money at all, I can just put that 0 so that I have hundredths versus hundredths. My 5s are the same, so those don't matter. So now I'm going to look at these decimals, and I got 5 hundredths versus 50 hundredths. 50 hundredths is definitely more. Now let's look down at this next one. We got 25 and 5/10 versus 25 and 5 hundredths. This kind of problem tricks kids so much. It's pretty funny, but don't let it trick you. Remember, if you only have tenths, you want to add, or not add, but put something to make an equivalent hundredth. So if I just put that 0, I know 5/10 and 50 hundredths are equal to each other. So now I have 25 and 50 hundredths versus 25 and 5 hundredths. Well, 50 is definitely more. That 25 is not going to matter because they are already equal. So I'm only going to focus on my decimals. And 50 hundredths is a lot greater than 5 hundredths. All right, now here's a real tricky one at the end, but we're not going to let it trick us. There's so many things we could do. I can make an equivalent fraction here and put a 0 on the top and the bottom. So now I have 0 and 60 hundredths versus I'm sorry, 7 and 60 hundredths versus 7 and 60 hundredths. If I wrote this as a decimal, 7 and 60 hundredths. Okay, yeah, I know what you're thinking. They are equivalent. They're equal to each other. Yay, good job. All right, this is where it gets real fun. Decimals can also be shown on a number line, just like fractions. So if I'm looking at this number line that goes from 0 to 1 whole, it means there's lots of little fractions in between. And remember, when we are talking about number lines, we do not count the lines, we actually count the spaces. So I'm going to look at these bigger bars between and say, okay, how many spaces are there between the 0 and the 1? So I'm going to say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 spaces there, which means that my 1 whole is equivalent to 10 tenths. All right, so then we can go through and say, okay, well, that means the first one is 1/10. Oh, I need a thinner pen here. And our next one is 2/10, and so on, 3/10, 4/10, 5/10, 6/10. That is not a 10, Miss Kimmer. That is a 7. What are you talking about, crazy lady? Let's change that to a 10. 6/10, 7/10, 8/10, and 9/10. Don't worry about those little tiny ones in between. We'll talk about that in a second. So if I'm just looking at my big spaces, I have tenths. But I know that I can write fractions also as decimals. So I'm going to write them underneath. That would be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. I really encourage you to get some paper and practice drawing a number line like this on your own, because it means a lot more when you do it instead of just watching me do it. I know how to do it. I'm teaching for a long time. But try drawing a number line that's broken into tenths and labeling it on the top with fractions and on the bottom with decimals. So this number line does show me, like we know, that the fraction and the decimal are equal to each other. They are in the exact same spot. So 5/10 is in the same place as 5/10. And I know some of you will notice, well, that's also actually equivalent to 1/2 as well. It's right in the middle of our number line. So what are all these little tiny lines in between? Okay, well, I'm going to go down to this bottom number line. If I know that right here is 1/10, that means this is also 10 hundredths, because 1/10 and 10 hundredths are exactly the same thing. So if my 1 whole is 10 tenths, that also means that my 1 whole can be 100 out of 100, or 100 hundredths, because these are equivalent to each other. They all equal 1 whole. So if this first little notch here is 10 hundredths, what would be the one right before it? Right there. What comes right before 10? Well, that would be 9 hundredths. I can't even see them because they're so small. And then the one right before it would be 8 hundredths. That means this first little tiny, tiny one right there, that would be 1 hundredth. 1/100th. This means on a 100th grid, which I'm not going to exactly draw, but that would just be one teeny, tiny, 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 tiny little square colored in, and that's it. It would be so dinky. Which means that all my decimals can be found on this number line somewhere. So if, for example, if I know that this is 3/10, I know that it is also 30 hundredths, because 3/10 and 30 hundredths are the same thing. So if I was looking for 37 hundredths, I could easily find it because I know where 3/10 is. 3/10 is the same thing as 30 hundredths, and I would count and find the seventh one. There's 31, 32, 33, 34, 35, 36, 37, and there it is. I would find my 37 hundredths, which can also be written as 37 hundredths. Ooh, isn't that crazy? You might have to watch that twice to understand what's going on here, but you really look at it, it makes sense. So for example, at 1/2, if I know that that is 5/10, I also know that it is 50 hundredths. So if I wanted to find 52 hundredths, I would go 51, 52, and there it is, 52 hundredths. Or as a fraction, 52 hundredths. Crazy, right? I mean, math is just everywhere. All right, so what if I get a problem like this? It's not between 0 and 1. I'm being asked to find it on a number line. Oh my gosh, there's so much craziness going on here. Okay, well, we're going to not freak out. We're going to slow down, break it down. So our first step, we're going to look at this 4 and 1/10 and say, well, there's no hundredths there, so I'm going to give it a hundredths. So this is 4 and 10 hundredths versus 3 and 66 hundredths. Well, you can already tell that, 4 is greater than 3, so that one is bigger. But where would all this be on the number line? Well, I can tell this is broken up in tenths because I can see those 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, okay, I can find 4 and 1/10 then. I know it's bigger than 4. So I'm going to start at the 4. 4 and 1/10, well, that would be right after. It'd be 4 and 1/10. Or 4 and 1/10. So there's that one. There's 4 and 1/10 right there. Where is 3 and 66 hundredths? Well, it has to be bigger than 3 because there's the 3. And it's got to be greater than 3 because this number up here, 3 and 66 hundredths, is greater than 3. So I'm going to look for, first I'm going to look for where is 6/10. That will be helpful. So I got 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. So there's 3 and 6/10. But I need 66. So remember that in between are all the individual little hundredths. So it'll be 61, 62, 63, 64, 65, 66, 67, 68, 69. It's really drawn poorly, but it's hard to do on a computer. So 66 would be somewhere in there. 61, 62, 63, 64, 65, 66. Right about there would be my 3 and 66 hundredths. And as a fraction, 3 and 66 hundredths. So if I look at where these numbers fell on this number line, I can tell that 3 and 66 hundredths is less than or earlier in the number line than 4 and 1/10, which means that 4 and 1/10 is greater. Woo, that's a lot, but you can do it. Give it a try. Draw some number lines, plug some numbers, and you'll practice on your assignments this week. Good luck.